The last topic for this module is analysis of variance, usually abbreviated as ANOVA. Some people say ANOVA. I always say ANOVA because my graduate statistics teacher's at ANOVA, and it's an abbreviation for analysis of variance. But it doesn't really matter how you pronounce it as long as you know what it is that you're talking about. It's similar in a lot of ways to the independent samples t-test in that you're comparing subsets of respondents on some numeric variable. It's also similar in some ways to the chi-square test in that it's purely a two-tailed test and you're looking for differences across categories, but you're looking at differences in the mean across categories as opposed to the cell counts. Now, to sum it up as simply as possible, the main difference between ANOVA and an independent samples t-test is that independent samples t-test is for exactly two groups. ANOVA is for three or more. And then again, as I just said a moment ago, ANOVA only tests for differences. Now, you can test for differences with the independent samples t-test, but you can also you can do the one-tailed tests, and you can test something being higher or lower. You do not have that option with analysis of variance. It can only establish there are significant differences across the groups. If you are interested in the difference between two specific groups from within that three or more, you can drill down into those pairs using independent samples t-tests. But the analysis of variance tests whether you've got variation across, again, three or more. So to run it, it's on that same menu again. Analyze, compare means. It's the last option there, one-way ANOVA. So we're going to continue using the music variables. And let's hypothesize that preferences for gospel music vary by religion. So I'm going to exit the PowerPoint again, and we'll go right into the SPSS file. So I've still got everything filtered for 1993. I'm going to analyze, compare means, one-way ANOVA. And my dependent list is the variable, the numeric variable. In this case, gospel, that rating of their preference for gospel music. The factor is going to be the variable, it's like the grouping variable in your independent samples t-test. But here, it's just called a factor. And the one-way analysis of variance will look at the means across all of the groups that are in that variable. So unlike the independent samples t-test where you had to define the groups, there's nothing here to define. If you wanted to collapse groups like we've been doing for chi-square, like if you wanted to do Protestant, Catholic, and other, you'd have to create a new version of the variable. So like we've done in previous modules, you just create relig 2 or something like that. Okay. Now you also want to go in, there's an option here that you're going to want to check off. Click on options. There, under this box, you'll see statistics descriptive. Generally speaking, you're going to want to check that off. You're going to want that every time you run the analysis of variance. And the reason is, if you run this without that, the only output you're going to get is an f-test, but you won't have any sense of what's going on. You'll just know, oh, there are significant differences across the groups, or there aren't, but you won't know what those differences are. So generally speaking, I always like to include the descriptives when I'm running an analysis of variance because I want to know what the story is, right? If it's significant or not significant, that in and of itself is not that interesting to me. Okay, so we'll click on paste, and that will create this syntax. If I highlight it and then I run it, and you can see the descriptives here, this part here, this is what is run only if you check off descriptives. If you didn't check that off, the only thing you're going to get is this. And the answer is yes, it's significant. There are significant differences in their ratings of gospel music by religion. You want to have a story, right? So the story is here in the mean. So what is the story? Again, remembering that lower values mean they like it more because that's the way the variable is coded. And what you're seeing here is, at least directionally, Protestants like it the most, 2.11, followed by Catholics, 2.75. And then you've got the other groups are all, less preference for gospel music, which, that makes sense, right? Now, we haven't tested whether Protestant is significantly, more than Catholic. That would require an independent samples t-test. We haven't tested whether Protestant is significantly different than Jewish. Because, again, same thing, you'd have to run an independent samples t-test there. They'll probably see that's like the biggest difference. That's the best score and the worst score in the bunch. And so probably those are significantly different given that we have significant differences, but you would still need to run a separate test to pick that out. So this is your big two-tailed test, just like the chi-square. It's the same as saying, the expected counts across all those cells, vary by column. And that's what you're getting here. It's just that it's means. And so here I've reproduced the output here in the PowerPoint slide, and I'm just circling it. That's the analysis of variance. That's the test. And again, I've mentioned before, it's an F test. So we'll move on to exercise 9. I need you to change the filter back so that it's the 1987, 88, and 89 data, and test whether religion has an effect on the highest year of school completed. So go ahead and do that. Pause the video, and when you're done, come back. All right, and welcome back. I'm going to go back into my SPSS data file. I have to change the filter again, so I'm going to do data select cases. If condition is satisfied, I'm changing that if condition to year equals 1987 or year equals 1988 or year equals 1989. I'm clicking paste. I'll run the filter, go back into my data file, and now I want to do analyze, compare means, one-way analysis of variance. I'm taking out gospel because we're looking now at highest educational attainment, right? The most, how many years of education. So that's this variable EDUC. And we're still doing it by religion. I don't think I need to change the options. It should still be there because I checked it off, descriptives. And then we'll paste. So we can run our select and then run our syntax. And what we get here is, again, here's the story. Then, 12 years of education would be graduating high school. What we're seeing here is that Jewish respondents have the highest average number of years, or I should say the highest year of school complete, highest year of school completed, with Protestants with the lowest average, the overall average of 12.5. And again, the statistical test itself is here. And so there are significant differences in educational attainment, would usually be the way we would describe this, by the different religions. I have this output pasted into the PowerPoint slide, and so maybe you could see it a little bit better here than just looking at my SPSS output. But so long story short, yes, statistically significant. So I want to wrap up by using this summary. I mean, really, the trick here is knowing which test to run when, right? And so how do you know? As I stated in one of the earlier videos, the most important thing is that you're able to identify the level of measurement of the variables in your question. If both variables are categorical, nominal or ordinal, you're looking at crosstabs with chi-square, phi, Kramer's V. If one variable is categorical and the other is numeric, then you're comparing means, and that's everything we've been talking about in this module. If both variables are numeric, well, that's what we're going to cover in the next module. So if you're running crosstabs, so both your variables were categorical, you ran crosstabs. If it's 2x2 table, you're looking at phi to determine the strength of the relationship, and anything else, you're looking at Kramer's V. When you're comparing means, if it's just one mean versus a test value, that one's usually pretty easy to pick out. Right? The one sample t-test. One variable, two groups is an independent samples t-test. One group, two variables, paired samples t-test. One variable, three or more groups, analysis of variance. So use this as your checklist, starting with the level of measurement of your variables, and then depending on which, path you're going down, the secondary list of decisions. One-tailed versus two-tailed hopefully is clear. Two-tailed, you're asking, are they different? Are they the same? And one-tailed, you're asking, is one more or less, higher or lower?